see what are the factors that affect the corona. These are the factors which affects the corona called as supply voltage. It depends upon supply voltage. Next, condition of the conductor surface, whether it is a smooth surface or uneven surface. So those factors, the surface, conductor surface will decides the corona. Also depends upon air density factor, depends upon the system voltage. Next, spacing between the conductors. These plays a major role, and these are the factors which affects the corona. Let us see step by step, one by one, how it is going to affect the corona. The first one, if you check it, effect of the supply voltage. So if as I told you, the operation of the entire corona depends upon the voltage only. If at all if the voltage is increasing, then obviously the appearance of the corona also increases, means directly proportional. So if the supply voltage is high, corona loss is high in the lines directly. Then in low voltage transmission lines, the corona is negligible. Mostly the corona is applicable or observed in the high voltage transmission lines, because the electric field intensity is insufficient for ionizing the air. Because the electric field intensity whatever developed around the conductors is not having that much capability, that is insufficient to start ionization. So this is about the supply voltage. So supply voltage is nothing but if the supply voltage increases, operating voltage increases, obviously the corona process also increases. And the second one is condition of the conductor surface. So in general, if the conductor is smooth, if the surface of the conductor is smooth enough, then the electric field intensity will be more uniform as compared to the rough surface. If the electric field intensity is more uniform, then obviously it takes some more time. It requires the very high voltage to break down the air around the conductor. Whenever it is an uneven, immediately the electric field intensity, its magnitude is sufficient to break down the air. So that for rough surfaces, corona starts prior. Okay. So the roughness of the conductor is caused. Then what are the reasons for the roughness of the conductor? The reasons for the roughness of the conductor is accumulation of the dirt, that is deposition of the dirt, and next dust, also by scratching of the conductors. So if the conductors are smooth, then occurrence of the corona will be less. If the conductor surface is rough, because of these factors, because of these reasons, if the surface of the conductor is rough, then immediately that conductor will be subjected to corona for less voltages itself. Then the rough line decreases corona loss in transmission lines. So sorry, this is increase. The rough lines increases the corona loss in the transmission line. This is about the surface of conductor surface. The third one is the air density factor. Air density factor called as delta. So the corona loss, it is inversely proportional to the air density factor. Corona loss PC is inversely proportional to air density factor. So if you check it, the transmission lines passing through a hilly areas may have higher corona loss, because than that of the similar transmission lines that are having in the plain areas. Because in hilly areas, the air density is low. At hilly areas, since the air density is low, for hilly areas the power loss due to corona loss will be high. So it is inversely proportional to air density factor. And the fourth one is effect of supply or system voltage. So mainly this corona depends upon its electric field intensity, where the air starts ionizing. If you check it, the electric field intensity in the space around the conductors depends on potential difference between the conductors. If the potential difference of the conductor is high, if the potential difference between the conductors is high, electric field intensity is also high. If the electric field intensity is high, then the corona production is also high. So that the corona losses increases with increase in the voltage. It is directly proportional, similar to our operating voltages. Okay. So the next one is the spacing between the conductors. So in spacing between the conductors, if you check it, if the distance between the conductors, we check it. If the distance between the two conductors is much more as compared to the diameter of the conductor, then the corona loss occurs in the conductor. So in general, the maximum air, if you observe now the spacing, if the spacing is more, obviously the corona loss also increases. Okay. So total, if you check it, there are five factors which affect the corona. They are effect of the system voltage. Next, the second one is the spacing between the conductors, surface of the conductor, the third one, fourth one is air density factor, and the fifth one is diameter of the, that is air density factor, and spacing of the conductors on the transmission line. Let us see. As we came to know that corona is observed for high transmission lines, HV lines, then what are the disadvantages of this corona occurred in electrical transmission lines? So we know that the power loss is occurred due to the glow of the conductor. Whenever the power losses increases, then the efficiency gets decreased. That is the direct disadvantage. And the second one, we know that the noise is appeared around the conductor, which will further leads to the power loss, thereby again the efficiency is decreased, transmitting efficiency gets decreased. And next, because of the audio noise and also the visual glow appearance, immediately the conductor is subjected to vibrations, so that the conductor will vibrate its position. Whenever the conductor vibrates, then the weight of the conductor increases, which will be directly affected on the insulator. So there is a there may be a chance of failure of that insulator. And the fourth one, the conductor becomes corrosive due to the ozone gas production. As we told, the corona phenomenon is observed with three features called as luminous glow intensity observation, and next hissing noise is observed, followed by production of the ozone gas. Whenever this ozone gas is produced, then it forms a chemical reaction with the conducting material, so that a corrosion occurs on the conductor, which will decreases its lifespan. Decreases the lifespan of the conductor. And next, because of this all these features, the ohmic value drop increases. As the ohms increases, obviously the voltage drops also increases. And the sixth one, the corona power loss reduces the efficiency. As I told you, all this will reduce the efficiencies. It is a direct disadvantage of efficiency decreasing. And finally, whenever this corona is observed, then we can observe a non-sinusoidal signals. Whenever there is a non-sinusoidal signals, obviously there will be an interference, electromagnetic interference called as radio interference and TV interference on the transmission lines which are nearer by the communication lines. So interference has been observed. These are the disadvantages. Then at last we will see how to minimize this corona. As we came to know that whenever the transmission lines are subjected to high voltages, then it will leads to the corona, will have many disadvantages. Then how to minimize this corona? So there are three ways to reduce this corona. They are with the help of the conductor diameter, with the help of the voltage of the line, spacing between the conductors. Let us see one by one. The first one is the conductor diameter. So observing the conductor diameter, the diameters of the conductors can be increased. If at all, if the diameter of the conductor D gets increased, then by using, how to increase this diameter? Either by using hollow conductors or bundled conductors or ACSR conductors. By using any of these three called as hollow conductors, ACSR conductors and bundled conductors, we can increase the diameter. If the diameter gets increased, then the corona loss will be minimized because it takes more amount of voltage to break down the air. And next, second one, how to minimize the corona? The corona is minimized by voltage of the line. So as we know that the voltage is fixed due to some economic considerations like Kelvin's law. Okay, so the voltage is fixed, therefore it depends upon the disruptive voltage, it depends upon the spacing. If the conductors are spaced with a large distance, obviously the voltage, the disruptive voltage magnitudes gets increased. And the last third one, spacing between the conductors. If you check the spacing between the conductors, if the space between the conductors increases, then the voltage drop increases, due to which increase in the inductive reactance. As we know that if the spacing between the conductors D gets increased, the reactance XL gets increased, so the drops gets increased. Of course, we are having an advantage that VD gets increased. In addition to this VD gets increased, there are drawbacks. That is why the spacing between the conductors is not done as an effective method to minimize the corona. So the summary. Total in this class we have observed 4 factors called as skin effect, the non-uniform current distribution, proximity effect due to the mutual flux linkages, and next Ferranti effect, where we can observe that the receiving end voltage is greater than sending end voltage, and the last one, corona. Because of air around the conductor gets ionized, 3 factors are observed. They are luminous glow, hissing noise, and also production of the ozone gas. These are the total 4 effects we have discussed in today's class. Their formation, how to minimize all these 4 effects are discussed in detail in today's class. Thank you.